across the Ravi river near village Bajoli in Himachal Pradesh. Here we can see the terrain and location of the dam. Let us take you through the process of constructing the dam. Before the construction begins, the river flow needs to be diverted to make excavation and construction activities possible at the dam location. This is done by diverting the river water through a diversion tunnel that bypasses the dam location. Excavation inside the diversion tunnel is carried out by drill blasting using a 2-boom hydraulic drill. The excavated material is stored near either end of the tunnel. The diversion tunnel is excavated from both the upstream as well as the downstream ends, gradually progressing towards each other. Simultaneous to river diversion, excavation for dam abutment, both in soil and rock, is taken up. Excavation is carried out with a small excavator and 1-boom hydraulic drill. The abutment slopes are excavated in stages until the river water level is reached. The excavated material is stored on either bank for further use in coffer dam construction. The excavated slopes are stabilized by installing rock anchors and spraying shotcrete. Upstream and downstream closure dikes are constructed using the excavated material by the end-on method. Dikes divert the river flow through the diversion tunnel at upstream and prevent the downstream water going back to the dam site. Upstream and downstream coffer dams are then constructed using the material excavated from the abutment slopes and the diversion tunnel. Water between the coffer dams is pumped out to expose the river bed. Further excavation is now carried out up to the dam foundation level. Simultaneously, tower cranes, batching plant, wet belts and other construction facilities are erected at appropriate locations. Let us now understand in detail the trajectory of material movement involved in the process of building the dam structure. Dumper trucks travel via an approach road to the aggregate silos and dump the crushed aggregates in the respective silos. A conveyor carries aggregates from the silos, one size of aggregates at a time, to the rotary feeder. The rotary feeder mechanism directs the aggregates flow to the respective conveyors and subsequently to the hoppers in the wet belt system. Hereon, all the facilities are covered and insulated to avoid heat loss. The conveyors carrying aggregates of size 10 mm and sand pass through a chilled air blast, while larger aggregates pass through wet belts with chilled water spray with temperature of 2 degrees centigrade. To allow the extended time of travel for the aggregates in the wet belt, the conveyors move at a much lower speed. The temperature inside the wet belts is maintained at 4 degrees centigrade. Water from the cooled aggregates is removed by passing it through the dewatering rotating screen at the other end of the wet belt. Aggregates thus cooled are then carried via a closed conveyor and stored in pre-cooled storage bins. A strike plate mechanism installed over the conveyor directs the aggregates to fall in appropriate storage bins. Aggregates from pre-cooled storage bins are now carried via a closed conveyor to the batching plant weighing mechanism and further for mixing. At the batching plant, aggregates are mixed with cement coming from the cement silos and chilled water in the required proportions to make a concrete mix of the desired consistency. The concrete thus made is transferred into the concrete bucket placed on a truck that carries it to the dam location. The crane keeps down an empty bucket, picks up the loaded one and delivers the concrete to the desired location of the concrete fill that is demarcated by steel shuttering. A concrete vibrator is used to ensure that the pour is even and free of air bubbles. Concrete is placed in layers of about 300 mm thickness along the block width in a 3-meter layer at a time so that cold joints during placement are avoided. With slabs spanning the width of the dam, the entire structure is eventually built. Temporary structures like dikes and cofferdams at upstream get submerged underwater, while the downstream structures are removed after completion of the structure. What we see now is the completed dam.